Hi, Assalamualaikum. Today, our group, which is group 2, will present about the reduction reaction in redox reaction. So this is our group members, which is me, Tihani Patricia, and Nur Afifah, Fatina Jiha, Nur Laili, and Hanis Hamira. So in this presentation, it will include the introduction, list of common reducing agent, reduction reaction by reducing agent with different compound, summary, and a little bit question. So in this introduction part, before I start my presentation, I would like to play a video to all of you.
Almost 1/3 of the chemical reactions taking place around us are some form of oxidation and reduction reactions. So what are oxidation and reduction reactions? And where do we find them? In the 1700s, the word oxidation originally meant a reaction with oxygen, where oxygen was added to a compound. This was because oxygen was the first known oxidizing agent. However, the definition of oxidation has become more general these days, including other types of reactions. In modern chemistry, oxidation means the loss of electrons during a reaction, and it doesn't necessarily involve oxygen. The opposite process of oxidation is called a reduction. The word reduction originally meant removal of oxygen, but in modern chemistry, once again, it means gain of electrons during a reaction. In a chemical reaction, one species loses electrons as the other species gains electrons. Therefore, oxidation and reduction reactions take place altogether. That's why oxidation-reduction reactions are simply referred to as redox reactions. Oxidation? Reduction? Electrons? What? Are you confused? Let's just remember the acronym Leo the Lion, GER. What this stands for is loss of electrons is oxidation and gain of electrons is reduction. Or you can remember it as oil rig, which stands for oxidation is loss, reduction is gain. That is loss and gain of electrons, of course. Now, where do we find oxidation and reduction reactions in everyday life? Number 5, combustion. Burning wood in the fireplace, burning coal, fireworks, lighting a matchstick. These are typical examples of combustion. Combustion is a redox reaction where a compound being burnt is oxidized and oxygen in the air is reduced. Combustion reaction is also used to fuel the space shuttle. The fuel tank of the space shuttle contains super cold liquid hydrogen and liquid oxygen in separate compartments. When they are mixed and burnt, they form water and release enormous amounts of energy. Talking about space shuttles, do you know what happened to the Space Shuttle Challenger? It was in January 1986, the Space Shuttle Challenger broke apart 73 seconds after launch, killing all 7 crew members. Well, what caused this disaster? One investigation concluded that due to an unusually cold weather that morning, a rubber seal in the shuttle's booster rackets became stiff. This allowed superheated gas to escape and burn through the external tank. The external tank collapsed, spilling liquid hydrogen and oxygen inside. As you can imagine, mixing liquid hydrogen and oxygen created the huge fireball. This was a combustion reaction horribly gone wrong. Number 4, corrosion. Another classical example of oxidation is corrosion. Corrosion is a process where metals are eaten up gradually by the oxygen in the air. In a way, corrosion is a very slow combustion. Most metals react with oxygen to form oxides. The oxide of iron is commonly known as rust. In this reaction, oxygen gets reduced while iron gets oxidized.
So, from
Almost
the video,
1/3 of the
it's explained about the oxidation and reduction process. But today, our group will focusing on the reduction process. So what is reduction reaction? So reduction is the transfer of electron between species in a chemical reaction where there is a process of gaining electron or a decrease in the oxidation state by an element. So in the simple way, we can use the acronym which is OIRIG, where the O is oxidation is loss and RIG is reduction is gain. And of course, the loss and gain of electron. So next, I explain about the reducing agent. So what is reducing agent? Reducing agent is the substance that tends to bring a reduction by being oxidized and losing electron. So reducing agent tends to give away electron, and a good reducing agent atom has low electronegativity. The atom or molecule have very small ionization energy. It has good ability to attract the bonding electron. The stronger the tendency to lose electron, the stronger it is as reducing agent. So based on this table, the strongest reducing agent will have large negative standard potential. As we can see in the table, lithium is the strongest reducing agent, even though it has higher ionization energy, but because of it has large amount of hydration energy, make it strongest reducing agent. So reducing agent is stronger when it has more negative reduction potential and weaker when it has more positive reduction potential. So this is the list of common reducing agent. Lithium, for example, like lithium aluminum hydride, sodium borohydride, ascorbic acid, tin chloride, zinc sodium thiosulfate, oxalic acid, and sodium sulfate. So next, I will pass to the next presenter.
Thank you, Tiani. Now I will present about the reduction reaction by reducing agents of different compounds. Next. Okay, so this is the first reduction reaction, which is catalytic hydrogenation, and the reducing agent used is hydrogen gas. So some of the carbonyl compounds that can undergo the hydrogenation, and some of the carbonyl compound will give no reaction to the hydrogenation. The example of the carbonyl compound that can undergo the hydrogenation are alkene, alkyne, and acyl chloride. However, for the carboxylic acid, ester, and amide, they will not undergo the hydrogenation reaction. So, when there is the presence of catalyst, either platinum, palladium, or nickel, alkene and alkyne will be reduced. For example, here, ethene will be reduced by hydrogen gas in the presence of palladium to give the product of ethane. However, for 2-pentyne, will be reduced to give the initial product of 2-pentene. If this reaction undergo the hydrogenation for the second time, it will give the final product of the pentane, which is the most saturated because alkene with single bond is saturated compared to the alkene and alkyne that have double and triple bonds, which are unsaturated. Next, if Lindlar's catalyst is used, the hydrogenation of alkene will be reduced by hydrogen gas in the presence of Lindlar's catalyst to form alkene in cis or syn formation. Next. Okay, and then if the catalyst used is either sodium or lithium and ammonium, it will reduce the alkyne into alkene. Same as the Lindlar's catalyst, same as when the Lindlar's catalyst is used. The only difference is that when this catalyst is used, it will give the product of alkene by in-trans or anti-formation. Next. Okay, so for the second reduction reaction, which is addition of hydride ion and proton, the reducing agent used in this reaction is either lithium aluminium hydride or sodium borohydride, and water or hydronium ion from acid. So in this reaction, nucleophilic addition reaction will be taken place, and hydride ion from reducing agent will act as the nucleophile. So here are a few examples of carbonyl compounds that are reduced to form alcohol by reducing agent, which is lithium aluminium hydride. Carboxylic acid, ester, aldehyde will be reduced to form the primary alcohols. Meanwhile, for the ketone, where it is the only carbonyl compound that will be reduced to form the secondary alcohol. Next. Okay, so here is the mechanism of ester to form the product of primary alcohol. So the hydride ion that act as the nucleophile from reducing agent will attack the carbon and then followed by the removal of the leaving group. After that, nucleophile, which is hydride ion, will attack the carbon for the second time, and the alkoxide will be protonated by accepting the proton. Next. Okay, so here is the mechanism of ketone to form the product of secondary alcohol. So it's the same. It's the same thing as before, but more simpler. Okay, the hydrogen ion from the reducing agent will attack the carbon, and the alkoxide will be protonated and forming the secondary alcohol. Okay, so that's it for my part. I will pass to the next presenter, which is Najiha.
Okay, thank you, Afifa. Okay, I will explain the formation of amine by reduction. Reducing agent is lithium aluminum hydride, sodium borohydride, and water. So as you can see, there are three types of amide, which is the first one is unsubstituent hydride, react with lithium aluminum hydride and water to become the primary amide. For mono substituent hydride will become the secondary amide, and lastly, disubstituent amide will become tertiary amine. And lastly, for the nitrile, we will be get the primary amine. For and then for sodium borohydride will be used to reduce aldehyde and ketone. Okay, next. Okay, for deoxygenation, it is the reduction of C double bond O to CH2. There are two methods will be used, which Clemmensen reduction and Wolff-Kishner reduction. For Clemmensen reduction, the molecule is stable in hot acid, while for the Wolff-Kishner reduction, molecule stable in strong base. Next. Okay, as you can see, they produce the same product, but for Clemmensen reduction, we use the zinc amalgam. And for the NaCl, and for the Wolff-Kishner reduction, we use hydrazine and potassium hydroxide. The difference with these two is Clemmensen is for acidic, Kishner is for the basic.
Okay, thank you, Fatina Jiha. So now I will give the summary shortly and simple on the reduction reaction. So we will recall back on what our friend presented just now. The first one, we already watched the video, so we can know the term of a rate, which is oxidation is loss, reduction is gain. Gain what? Gain of electron. The second one is reducing agent. The list of common reducing agent is lithium aluminum hydride, sodium borohydride, oxalic acid, ascorbic acid, zinc metal, and many more. For reducing agent, it tend to give away electron. The stronger the tendency to lose electron, the stronger it is as reducing agent. And the third one, when we use good reducing agent, it has low electronegativity. Based on the earlier slide, which is on the half reaction, the stronger reducing agent, negative standard potential, or we can call as reduction potential. The weaker reducing agent will have more positive standard potential or reduction potential. And the third one is reduction reaction with various type of reducing agent, which is we use catalytic hydrogenation. The reducing agent used is hydrogen gas. The first one is catalyst, which is platinum, palladium, or nickel. The alkene will be reduced with reducing agent, which is hydrogen gas. In the presence of palladium, will form alkane. and alkyne will undergo hydrogenation with the reducing agent hydrogen gas. In the presence of palladium, will form an alkene as an initial product and will undergo the second hydrogenation to form the final product, which is alkane. The third one is the catalyst used is sodium or lithium and ammonium. The alkyne will be reduced with reducing agent hydrogen plus. The second one is Lilus catalyst. The alkyne will be reduced with hydrogen gas to form the formation of cis alkene. The third one is catalyst, which is sodium or lithium and ammonium. Alkyne will form trans alkene. The fourth one, the addition of hydrogen ion and proton, which is the reducing agent is lithium aluminum hydride or sodium borohydride and water or the presence of hydronium ion. The carboxylic acid, ester, and aldehyde will form primary alcohol. However, ketone will form secondary alcohol. The formation of amine by reduction, we'll use the reducing agent such as lithium aluminum hydride or sodium borohydride and water. The first one, unsubstituted amide, will form primary amine. Monosubstituted amide will form secondary amine. Disubstituted amide will form tertiary amine, and the nitrile will form primary amine. The last one is deoxygenation, which is we use the two method, which is Clemmensen reduction, when the molecule is stable in hot acid, such as hydrochloric acid, HCl, and the Wolff-Kishner reduction. The Wolff-Kishner reduction, when the molecule is stable in very hot base, such as potassium hydroxide or potassium T-butoxide. It will use the hydrazine to form hydrazone and will be heated with potassium hydroxide to product. So I will pass the next to Hanis Hamira.
All right, so question time. Okay. So for the first question, predict the product of the following reaction. So the first one is ketone and the second one is aldehyde. So we use here is the reducing agent we use are sodium borohydride and also lithium aluminum hydride. So as we all know, if ketone, the product will be alcohol. Meanwhile, for aldehyde, the product will be primary alcohol. So this is the product form. Okay, next. So question 2. Predict the reducing agents and the solvent used for the following reaction. So here we have phenylethanone or acetophenone. So given here is hydrochloric acid. So since given hydrochloric acid, we know it is Clemmensen reduction. Meanwhile, if given strong base, so it is Wolff-Kishner reduction. So the reducing agent used is zinc amalgam. Alright, next. Okay, so last questions. Show the reaction mechanism. So we have here is acetophenone. Alright, this is the answer. Aluminum hydride here will prepare for nucleophilic attack. So actually here, the hydrogen ion will attack the carbon that attached to the double bond, and then the double bond will break. So actually in aluminum hydride, the one that attack is the hydride, right? So ALH3 will actually slow down the reaction. So that's why we need the carrier. So ALH3 will act as the carrier. So after the double bond break, so it will have extra proton. So it will be protonated. So protonation will occur by the water. So that is the product form, and also the side product, which is lithium hydroxide. So I think that's all from us. Thank you.